There are several different techniques that we can use to calculate correlations. Pearson product moment correlation is probably most common used to determine the linear degree between two variables. One stipulation of this technique is that scores are either ratio or interval. Spearman does the same type thing. The only difference is that, with Spearman, I use raw scores, I rank them, then compare the rank. So the Spearman is used to measure the linear degree between two sets of ranks. Now we are interpreting the correlation. One thing that is very important to know is that correlation only describes the relationship, and it does not suggest a cause-effect relationship. The only way for you to establish the cause-effect is conducting some forms of manipulation, such as what you do in the experimental design. With the relationship or correlation design, there is no manipulation. You can only say there is relationship. You cannot say one variable cause another variable to occur. In other words, you should not interpreting cause-effect with correlation studies. For example, there is a strong correlation between sales of ice cream and drown. That is, when the sales of ice cream increase, the number of individual drown in the rivers or lakes increases. You cannot say that the increase of ice cream sales causes the drown. Rather, we know that temperature is the mediating variable. Another factor that needs to be taken into consideration is that the ranges of the scores are going to greatly affect the relationship or R value. You don't want to have a range of scores as far as possible. Here is an example. On the far left, when we look at all scores, it indicates moderate to high correlation. However, if I only look at the upper right plots, there is no relationship at all. In the diagram on the right, if I look at all scores, there is no relationship. The R value is close to 0. But if I look at the right side of this plot, there is a linear relationship. So I do not want to have a large range of scores as far as possible. Another factor that is going to affect the interpretation is outriders. Outrider is one or two extreme data points. It can dramatically influence the value of the correlation coefficient. This is a particular illustration of how outriders can greatly affect the correlation. If you look at illustration on the left, basically there is no relationship. If you look at the right, you would say there is still a linear relationship by using R value. The R value is 0.85, which is fairly high. So just having that outlier greatly influences the outcome. We can also use a probability as we did with inferential statistics. So we can actually do hypothesis testing, control by using an alpha value. Again, we set alpha or p-value or significance level at 0.05. If the R value I calculated is based on my size of sample, and that R probability of the occurrence is low by accident or by chance, I would say that the correlation is significant. Is oftentimes considered when interpreting the correlation is coefficient of determination R squared. It is really a measure of meaningfulness. It allows us to measure the proportion of variability in one variable that can be explained determined from the relationship with the other variable. Prediction is based on correlation. The higher the relationship between two variables, the more accurately you can predict one from the other. Oftentimes we use correlation, and now we use regression to predict something. For example, GRE scores are used to predict success of graduate studies. Sometimes we try to predict a criterion such as percentage fat by the use of skin fold measurements, predict maximal oxygen consumption by a distance run. In sports psychology, athletes' achievement goals and situation motivation to predict performance, etc. In most cases, the predictor variables are less time-consuming, less expensive, and more feasible for mass testing than the criterion variable. Therefore, a regression is developed. Statistical technique for finding the best fitting straight line for a set of data. The line that is found is called the regression line. Purposes of the regression line are threefold. 1. Make the relationship easier to see. 2. Identify the center or central tendency of the relationship. And 3. Establish a precise relationship that can be used for regression. Each regression line can be expressed by an equation. Regression equations are very similar to the equation of lines to do in high school or college. In linear regression, we use one value to predict the other value. Here is one method we use to calculate the regression line that fit. Y is predicted / criterion score, A is the intercept, B is the slope of the regression line, and X is the predictor. Sometimes we also call independent / outcome and dependent variables. B signifies the amount of change in Y that accompanies a change of 1 unit of X. This type of correlation is useful only if a straight line is the best fit to the data. Anytime I use regression, I am not going to get the exact value. The differences between predicted scores and actual scores represent the errors of prediction and are called residual scores. If we compute all the residual scores, the mean is 0, and the standard deviation is the standard error of prediction, or standard error of estimate. Now I can use one predict the other. I can also use multiple predictors. Partial correlation, a technique of removing the influence of a third variable to determine the degree of relationship between two other variables of interest. For example, weight and strength increase regularly with age from 6 to 18. Over a wide age range, the correlation will be highly positive because of the common maturity factor with which they are highly correlated. In fact, the correlation may drop to 0 if the variability caused by age difference is eliminated. The primary value of partial correlation is to develop a multiple regression equation with 2 or more predictor variables. Semi-partial correlation, a technique of removing the influence of a third variable on one of two variables of interest to determine the degree of relationship between two variables. I have several variables, including several dependent variables and several independent variables. I might use canonical correlation. Canonical correlation. An extension of multiple correlation, but rather than one dependent variable, the objective is to correlate simultaneously several dependent variables and several independent variables. It develops a linear combination of each set of variables to maximize the correlation between the two sets.